Okay, this is the second to last video. In this video, we'll be covering 7.1, 7. And then the last video will be graphing quadratic functions, and we're done. Goal is to get all of this out by the end of the day, so probably cut that out. Yeah. All right. The square root property is weirdly straightforward. It says for any real number k, if x squared is equal to k, then x is equal to positive and negative root k, or plus or minus root k. Pretty straightforward. Ready? So I think the easiest thing is to do an example. Let's follow the example they give here, example 1. So initially, of course, your goal is always to get x squared by itself. You want 1x squared, not like 7x squared, 1x squared. So in this example, you have 4p squared is equal to 9, where p squared is your x squared, right? And again, we want 1p squared. How do we do that? Well, the operation between the 4 and the p squared is multiplication, so to undo multiplication, we can either divide or multiply by the reciprocal, multiply by 1/4. And so if we were to do that, you should end up with p squared is equal to 9/4. Then what do? You square root both sides. So you get p is equal to positive negative root 9/4. And if you remember from last week's video, or 2 videos back, I suppose, you can actually distribute this as positive negative root 9 over positive negative root, 4, right? But fundamentally, you can actually just break this down as root 9 is 3, root 4 is 2, and you're done. That's the square root property. Okay, now the next thing we want to do is talk about completing the square followed by applying the square root property. Okay, so to complete the square, this is what we, mean. Completing the square. Okay. So, generally speaking, right, a quadratic function is of the form ax squared plus bx plus c equals 0. And this isn't always nicely factorable. Not always, okay? So, for example, let's do an example. 2x squared plus 28x plus 80 is equal to 0. We want to solve for x, right? We want what x value makes this equation true, what x value makes the left-hand side equal to 0, okay? So the first step is, well, getting the leading coefficient to equal positive 1. So in this case, we're going to divide everything, including the 0, technically, by 2, all right? We'll do that in pink. Divide by 2, divide by 2, divide by 2. And that leaves us with x squared plus 14x plus 40 is equal to 0. There's 2 ways of looking at this, 2 ways of representing this, this following step. And I'm going to show you the way that I think is the most, how do I want to say this? Intuitive, okay? What we're going to do is we're actually going to scooch the 40 to the other side, like the steps say, right? Isolate the variable terms on one side. So that's going to leave us with x squared plus 14x is equal to negative 40, okay? Now, what does it mean to complete the square, right? If you remember, a square, a perfect square, right? A perfect square trinomial is of the form, right? This is a perfect square trinomial, and it's of the form a squared plus 2ab plus b squared, right? And so in this case, your a squared is your x squared, different a than the coefficient, okay? I'm sorry, I'm using the same letters. Your b squared is unknown, but you know your 2ab is 14x, right? Well, if 14x is 2ab, then reasonably, right? Reasonably, if 2ab is equal to 14x, and you know that x is equal to a, right? That's how we defined it here, right? Then you know that 2xb is equal to 14x, right? If you want to highlight it, you're welcome to. And then you can divide by 2 on both sides. Bx, we just rearranged the b and the x, is equal to 7x. Well, of course, x is equal to itself, so what must b equal? Well, b must, in this case, equal 7. Okay? So, given that little side quest, and this is how I loosely expect you guys to work it out. If there are other ways that you find more intuitive, that's fine. I think this is just the most intuitive and efficient, okay? We know that, oh, I shouldn't have done that. B is equal to 7, right? Which means B squared is equal to 49, right? Okay, if this is true, then you know that you can write this equation as x squared plus 14x plus this 49 is equal to negative 40. And remember, whatever you do on one side, you must do to the other to keep your equation balanced, right? So you're going to add 49 on the other side as well, just like that, okay? Now, the reason why we want to do this is because we're exploiting the fact that this is now a perfect square trinomial. It's of this form, right? Your a is equal to x, your b is equal to 7, so reasonably, right, you know that this is going to be x plus 7 squared, right? X squared plus 14x plus 49 is x plus 7 squared. And this is going to equal negative 40 plus 49 is going to be positive 9, okay? Just like that. And we can actually exploit the square root property now, right? Remember how we said, oh, if x squared is equal to k, then x is equal to positive negative root k, right? Well, you square root both sides, just like it says in step 4, right? You square root both sides, and all of a sudden you have x plus 7 is equal to positive negative both roots, okay? Both roots, 9, just like that. Okay, but if this is true, right, and this is for solving equations, okay, we're expecting both, okay? It's an or statement. If this is true, what is positive negative root 9? Well, we can simplify our problem into x plus 7 is equal to positive negative 3. It is both positive 3 or negative 3. Both are valid answers, right? And then, how do you get x by itself? You subtract 7. So you have x is equal to positive negative 3 plus 7. What does this mean? This means you have two solutions. X is equal to 3, positive 3, I'm so sorry, that's supposed to be a negative sign. Minus 7, like that. Or it can be x is equal to negative 3 minus 7, right? And if you simplify this down, you get positive 3 minus 7 is negative 4. Negative 3 minus 7 is negative 10. So your solutions are x is equal to negative 4 or negative 10. Or you can write it verbally as negative 4 or negative 10, just like that, right? You got all sorts of fun options here. And that's it. I recommend you plug it right back into this equation to make sure everything works out the way it's supposed to. But that's how you solve by completing the square, okay, my friends? An alternative method, and this is going to be nice for graphing later on, is to say 2x squared plus 28x plus 80 is equal to 0. Instead of dividing by 2, we factor 2 out. I know, it's a little silly. And we can factor it out as 2 parentheses x squared plus 14x plus 80 is equal to 0, right? And once you get to this point, you can say, oh, well, I know what value should be here. It's the same as earlier, right? It should be 49, right? It's the same as earlier. But of course, if you have that, what you're really saying is x squared plus 14x plus 49, but you know that this is being multiplied in. Do you see what I mean, right? If we add 49 on this side, all of a sudden, this side will no longer be equal to the original equation, right? So what you're going to want to do is you're going to want to say, on the 0 side, right, you can have that as 2 times 49. That's another option. All right, my friends, the next thing we will cover is the quadratic formula. Okay, so first, your equation needs to be of the form x squared plus bx plus c is equal to 0. Okay? Actually, that's it. 2. This is how you solve for x. This gives you x such that when you plug into equation, both sides equal 0. Okay? So, we ready? X equals, all right, I'm going to start color coding, all right? Negative b plus or minus the square root of b squared minus 4ac. So 4 times a times c all over 2 times a. Negative b plus or minus square root of b squared minus 4ac all over 2a. This works because of beautiful geometric properties that we're not going to get into. That's more of a pre-calc kind of thing. But yeah, that's how you do it. If you can't factor, or the factoring's looking kind of bad, quadratic formula will never fail you. Asterisk, and the asterisk is it just takes a while, and you might make mistakes with bigger numbers. Okay, that's it. That's the quadratic formula. It's just a plug and chug kind of deal. Oh, of course, the caveat is a can't equal 0, or else you have a linear function, right? And that's no fun. I suppose a could equal 0 and like everything would be fine. It would just be linear. Yeah, that's it. Oh, here's a side note. The discriminant is the b squared minus 4ac part. Minus 4ac. Okay, now hear me out. Let's look at our quadratic formula really quick. Okay, this guy. A number has, generally speaking, 3 options. It can be positive, 0, or negative, yeah? Okay. Ready? If b squared minus 4ac is greater than 0, what do we know? The square root of a number bigger than 0. What is it? Is it positive, negative, or 0? It's positive, okay? If it's a positive number and you have x is equal to negative b plus that positive number, you get, some number, right? But if you have negative b minus that same positive number, right, reflected here, all of a sudden, you have a second value, okay? So when the discriminant is greater than 0, you will have 2 solutions. Okay, what about when the discriminant is less than 0? What is the square root of a negative number in real space? Right, it doesn't exist. So you cannot have a square root of a negative number, which means you cannot have negative b plus or minus whatever that value is, because it's imaginary. We don't have to worry about that. Which means there are no real solutions. Very good. No real solutions. Okay? All right. And now what if the discriminant is equal to 0? What is the square root of 0? It's 0. What's negative b plus 0? Negative b. What's negative b minus 0? Negative b. And then, you divide both by 2a. And, oh, wait, it's the same number, right? It's the same real number. So 1 real solution. Okay? The discriminant tells you whether you have 1, 2, or none real solutions. Okay? It's a really good way of vibe checking things. So it's like you're looking at this and you're like, I don't know if it's worth my time. Run the discriminant. If it gives you a nice positive number, you're going to have 2 solutions. If it gives you a negative number, you can just say, hey, the discriminant's negative, I quit. There's no real solutions. Discriminant 0, you say, there's 1 solution. I only have to do 1. That's it. Quadratic functions. Woo. Let's do some examples. Let's start with 12p squared minus 4p plus 5 is equal to 0. We want to solve for a p in which this equation is true. And like I said, I'm only interested in real space. Okay, so like I said, let's start with the discriminant. Again, I'm going to go in and actually label each moving part so you guys know what you're looking at. All right, you don't have to color code if you do not want. This is our A, this is our B, and this is our C. All right, the discriminant is going to be b squared minus 4ac. Okay, b squared, b is -4, not just 4, -4. Okay, so b squared is -4 squared minus 4 times a, which is 12, times c, which is 5. Okay, and this means -4 squared is 16, minus 4 times 5 is 20, and then times 12. You can do this all in one step. I like to do in 2 so I don't lose my place. And then I have -16 minus 20 times 12 is 240. Is this greater than 0, equal to 0, or less than 0? You tell me. This is a minus sign, by the way. Should be negative. Less than 0, which means this has no real solutions, and you can call it a day. Easy, right? Let's do another one. Let's do -x squared is equal to -2z minus 35. So what we're not going to do is we're not going to call this b. It's not b yet because it's not in the correct form. So let's put it in the right form. Oh, also that should not be a z, that should be an x. Okay, this is going to be -x squared plus 2x plus 35 is equal to 0. You're going to ask me, Amanda, really quick, does it matter which way we move our numbers? It does not. As long as everything's on the same side, it does not matter because it's up to dividing everything by -1. Okay. All right, this is our A, B, and C. So our discriminant is going to tell us b squared minus 4 times A, which is -1, times C, which is 35, right? B squared minus 4ac, yep. Okay, which is going to be 4 minus -4 times 35, right? Which is going to be 4 plus 4 times 35. Again, you can switch the signs in a way that makes more sense to you as long as you're not breaking any algebra rules. 4 times 35 is 140. Yep. So 4 plus 140 is equal to 144. And this is greater than 0. And this means we have 2 solutions. Cool. Great. And if we have 2 solutions, we can use the quadratic formula and you can say x is equal to -b, which is -2 plus or minus the square root of b squared minus 4ac. We've already established that that's 144. All over 2 times a. A is -1, just like that. And then you have -2 plus or minus square root of 144 is 12, all over -2. -2 plus 12 is 10. It's a 10 over -2, which is equal to -5. And -2 minus 12 is -14. And then, over 2 is +7, which means you get x is equal to -5 and +7. And if you want this in factored form, we know that these are the x values such that when you plug it back into here, your function is, your equation is equal to 0 on both sides. So in fact, this is a very fast way of getting the factored form of this guy. Once we get things factored, right, you have like x plus a is equal to 0, sorry, x plus a, x plus b is equal to 0, right? And then x plus a is equal to 0, x is equal to -a. X plus b is equal to 0, x is equal to -b, right? Well, we have those values. The signs are switched, yeah? Given that, you know that this guy can actually be written as x plus 5, x minus 7 is equal to 0. And if you do it out, you should get that. Okay, so that's actually a really cute, fun way of quickly factoring something. So if I'm ever like, oh, factor this, and I don't tell you what form, you can just use a quadratic formula and make your life easier. If I don't insist on a specific form, just letting you know. So anyway, we have 2 solutions. That's how you do it. That's another way instead of factoring, or in addition to factoring. And let's try one more problem. Let's do Let's do 25x squared minus 20x plus 4 is equal to 0. Again, we're going to check the discriminant really quick. Because again, sometimes it's not worth, wasting your time. So b squared, -20 squared plus 4, minus 4ab minus 4ab. Okay. -20 squared is 400. Yes. And 4 times 25 is 100. And then you multiply by 4, which is 400 minus 400, which is equal to 0. Okay. Discriminant equals 0. How many solutions? 1. Okay. Okay. Now we can just do the quadratic formula. We know that x is equal to -b. So -b is 20 plus or minus the square root of b squared minus 4ac. We know that's 0. All over 2 times a. What is a? 25. Just like that. Plus or minus root 0. It's 0. Plus or minus 0 is not worth doing because it's going to be the same answer. So actually you're going to have -20 over 50. Well, ain't that nice? Because then this simplifies down to -2/5. And that's your one solution. X is equal to -2/5. You're probably wondering, oh, Amanda, how do we write this in factored form? I am so glad you asked. This will give you x plus 2/5 squared, right? Because it's both factors, x plus 2/5, right? It's equal to 0. It's the same as saying x plus 2/5 squared equals 0. But Amanda, hold up, calm down. 2/5 squared is 4 over 25. I'm so glad you pointed that out because here's a bit of magic for you. If you confuse easily, feel free to skip this section. Ready? If you were to do this out, you get x squared plus 2ab. So 2 times 2 is 4. 4/5 x plus 4 over 25 is equal to 0, right? What is the GCF? This is second one of right? What is the GCF of 1, no, let's try that again. What is a number in which you can multiply to all of these guys and get rid of all their denominators in one fell swoop? If you said 25, you would be right. Multiply everything by 25, watch this. Multiply this by 25, and this by 25, and this by 25, and 0 by 25, and you get, well, 1 times 25 is 25. 25x squared plus 4/5 times 25 is 20x, yeah? Plus 4/25 times 25 is just going to be 4, is equal to 0. Oop, that should be a minus, I'm so sorry. These should all be minuses. I found my error. Oopsies. Ready? Hi guys, sorry, forgot. There's a little error here. This should be plus because it's negative b, and b is negative 20, negative b is positive 20. There we go. Right, which means back in factored form, this should be should be a minus. Those should be pluses. No, I was right the first time. Yeah, that should be a minus, and yeah, there we go. And then all of a sudden, you multiply everything by 25. Back to the original equation. Ain't that magical? And that's pretty much it. Graphing is easy. We'll get to it. All right. Okay. Thank you, friends. As a little side note, an equation is said to be of vertex form. A quadratic equation is in vertex form. So f of x, an equation, is in vertex form if f of x is equal to ax minus h squared plus k. All right. Completing the square is important for graphing. You'll notice that there is a slight difference in how I wrote this problem versus how we put this form, right? Earlier we divided by 2. If you divide by 2 and it's an equation equal to f of x, if it's a function, bad things happen. There's a little bit of squishing around you gotta do. But other than that, we ball, all right? And let's do a quick detour, completing the squares for functions, okay? F of x is equal to 2x squared plus 28x plus 80, right? If we want to complete the square here, right, to have it into vertex form, it's the same exact process. You say, oh, this is the same as 2x squared plus 14x plus 80 on the outside. Again, you want the inside to be a perfect square. And we know that perfect square should involve a plus 49, right? So if we were to do that, we would get, 2x squared plus 14x plus 49, right? Plus 80. But here's the thing. These two functions are not equal. The first function doesn't have that extra plus 49 times 2. It simply doesn't, right? You put something in there that's not supposed to be there. And so how do we counteract that? You just subtract, right? And so you can write this as minus 2 times 49, right? Again, this is just completing the square, and then you end up with something lovely that is 2x plus 7 squared plus 80 minus 2 times 49 is 98, right? I think 80, 18, yes, 98, right? And this should give you 2 times x plus 7 squared minus 18. Okay. And this is great because it's in vertex form, which we will discuss in the next video, okay? So this is an important skill I want you guys to get comfortable with the idea of. We'll talk more about it later, okay? Sorry, I forgot to tell you guys one thing. Grade scope, I want problem recognition exercises for chapter 7, numbers 1 through 4, parts A and B for each. If there are no real solutions, you do not have to solve for the imaginary. General good practice is numbers 5 through 24, but I will not be grading those, okay? All right, that's all.